Hello, Algebra 2 students. Today we are going to be taking a look at word problems that correlate to your substitution and elimination, systems of equations types of problems. The first thing I want you to do is open your packet to this note worksheet. It is in there following the bookwork that you did yesterday. So this follows along, so you do not need to write down all of these word problems. Okay, so once you've opened up your packet, let's get started. The first problem says the school play reached the max attendance of 500 people. They charged $3 for children and $5 for adults. If their ticket sales totaled $2,060, how many children and how many adults attended? Well, we're asking for two different variables here. How many is the number of children and the number of adults. The first thing we want to do when we're working a problem like this is to label our variables. So if we let x equal the number of children and y equal the number of adults. It's always important to label your variables. So if we have two variables, we have two unknowns, we're going to need two equations to find those two variables. So I'm going to start with this first piece of information that says the school play reached a max attendance of 500 people. So there were 500 people at the play, 500 adults and 500 children. I can write an equation to represent that. The number of children, x, plus the number of adults, y, equals 500. So this equation represents people. Now the second part of the equation, or the word problem, they start talking about money. It says $3 for a child, $5 for an adult, and this is the total amount of money they raised. So I can write an equation, $3 for each child. Well, if 2 kids win, it would be 6. 3 kids win, it would be 9. 4 kids, 12. But right now I don't know how many, so it's x. So 3 times x plus, same thing for the adults. If 2 adults win, it would be 10. 3 adults, 15. 4 adults, 20, and so on. But again, we don't know how many adults, so we're going to say 5 times y equals the total amount of money they brought in, $2,060. Now, over the last few days, we've spent time solving systems of equations, so you have a choice right now. You could solve by substitution or you could solve by elimination. I'm going to go ahead and solve by substitution. You might have picked elimination, and that's okay. So I'm going to rearrange. I'm going to solve this first equation for x. So if I subtract this y over, it would be x equals negative y plus 500. And I'm going to take this and put it in for y in my second equation. So this is going right here, for x. I'm making things up. Okay, so my new equation after I substitute in would be 3 times negative y plus 500 plus 5y equals 2060. And then I'm going to go ahead and solve this. So negative 3y plus 1500 plus 5y equals 2060. I'm going to combine my like terms. So 2y plus 1500 equals 2060. Subtract 1500. 2y equals 560. And divide by 2. So y equals 280. So now I'm going to go ahead. Okay, so we need to now find an x value because we have a y value. I'm going to use this original equation, x plus y equals 500. Oops. Just scratch that out. Try that again. X plus y equals 500. And I'm going to put y in there. So x plus 280 equals 500. Subtract 280. And x equals 220. Okay, but the better question is, what does this mean? Okay, so make sure you answer the question. The question was how many adults and how many children attended. So when I answer my question, since X was 220 and X stood for the number of children, I would say 220 children and 280 adults went to the play. Perfect. Okay. So let's just review what we did. We first started by labeling our variables. We have two variables, so I need two equations for my two unknowns. I wrote two equations, one based off of people, one about money, and then I used substitution to solve my equation. I finished the problem by making sure that I answered the question in terms of the problem, children and adults. All right, let's try another type of problem. Okay. Since you're saving money for college and can't decide if you should make an initial deposit of $300 and add $50 every month, or start with $100 and add $75 a month. Okay, let's start with this first question, which says, when will you have saved the same amount using either method? Okay, so this is question 1. We've got several questions in here. If you save for 4 years, which is the better method, that would be question 2, and then we have to answer question 3. All right, so it's important to note that we are doing two different savings accounts. So that means our equations have to be for two different accounts. For savings account 1, we're depositing $300 and adding $50 every month. If you're like me and you're thinking this sounds like y equals mx plus b, you are correct. $50 is a rate of change. $300 is a flat fee. You put it in there one time. Same thing here. $100 in the account, $75 every month. 75 is a rate of change. $100 is a flat fee. You put it in there one time. So let's start by defining our variables. If we let x be the number of months and y equal total money in accounts. Okay. I'm going to write an equation. Y equals 50x plus 300 for the first account, and y equals 75x plus 100 for the second account. Again, two different accounts, two different equations. Needed to pick up on that this is in the form y equals mx plus b. Okay, so question number 1 deals with when is the amount of money the same in both accounts. So what I'm going to do is I'm going to use the substitution method, and I'm going to set these two equations equal to each other. So I'm going to take this 50x plus 300, put it in for y. When I do that, I get 50x plus 300 equals 75x plus 100. And I'm going to solve that equation. So I'm going to subtract 50x from both sides. I get 300 equals 25x plus 100. I'm going to subtract 100 from both sides. 200 equals 25x. Divide by 25. And 8 equals x. Again, before I move on, I'm going to make sure I answer the question. And the question was, when will the amount of money be the same? Well, after 8 months, both accounts will have the same amount of money. Okay, so that was question 1. If I move on to question 2, which is if you save for 4 years, which method would save you more money? Okay. Well, I have my two equations, my two models for both accounts. All I need to do is plug in 4. So if I plug in 4 here, I get y equals 50 times 4 plus 300, and y equals 75 times 4 plus 100. Just do the math and we'll compare. So for this first equation, y would equal $500. For this second equation, y would equal $400. So obviously this first savings account would save you more money. So we would want to say that savings account number 1, that would be the best pick if we were going to only leave our money in there for 4 years. Well, question number 3, we're talking 10 years. So same thing. Y equals 50 times 10 plus 300, and y equals 75 times 10 plus 100. So on this one, y would equal $800. On this account, y would equal $850. So what we see is the longer we leave our money in the account, we're going to want to use the second savings account of a rate of $75 with an initial deposit of $100. Looks like if we're going to leave it in there before 8 years, this first account would make us more money. Okay, let's take a look over here. This is what I want you guys to do. We have some video examples, numbers 3 and 4. Tomorrow in class, we will go over those examples and see how you did. Thanks for watching my video.